Hello and welcome, dear clients of CTS. We are a professional supplier of lithium batteries, and this is Victor here, overseas sales engineer of CTS team. I'd like to make a brief introduction of electric vehicle system with this presentation. Hope it can be of some help to you. Here we go. There will be 5 parts: overall structure, methods, and standards of charging, main components, BMS, and battery pack. It's supposed to be a brief introduction, so I'm going to be really brief and clear. Now let's take a look at the structure. You could see that there are DC-DC, OBC, CTS battery pack, PDU and BMS, motor, and motor controller. Some might also call it inverter or MCU. This is a topology of a passenger car. Full structure is not demonstrated here. Of course, there are more parts on an EV. We are only focusing on part of the powertrain system here. What's more? Now this picture shows that how current flows across the whole system. An EV can either be charged with AC through OBC or charged with DC through PDU. And the battery cannot be only used to power the motor and MCU. It can also be used to charge onboard lead acid battery. Enough with the structure. Now let's take a look at part 2, methods and standards of charging. Currently, there are 5 major standards of charging worldwide. Type 1 and CCS1, it's widely accepted in North America and Japan, while CCS2 pretty much occupied EU market. GBT is only applied in China, and then there's Tesla. It can be seen in almost every country. I'm not sure if you have ever noticed that CCS is actually similar to Type. Here's some picture of them. Watch for the pin layout and you could see some resemblance here. CCS is an upgraded version of Type and it supports both AC and DC charging. Now you may have a rough idea of how different standards of charging. For the next couple of slides, I'd like to make some examples with different standards and help you understand how charging works. There's a GBT AC plug and charger here. The current is actually going through OBC and then charge the battery. You could clearly see how the current flows across the system, across OBC. A mobile charger can be connected to the grid on one side and a Type 2 or CCS connector on the other side. Now let's take a look at DC. This is a GBT DC charging plug. If you have ever noticed, it's completely different from the GBT AC plug. And here's how a battery gets charged by AC. DC. DC charging stations can be seen everywhere. What's different about DC charging is that it is usually powered by 3-phase power source. The current will go through the charging pile, which serves as an AC-DC, and then to the battery directly. OBC is not needed for DC charging. Okay, as fancy as all these standards and methods of charging can be, they cannot be achieved without several other essential components on electric vehicles. Now let's walk you through them. And for the next couple of slides, I will leave some time for you to read the text in case you can follow up. First, we have OBC, also known as onboard charger. OBC mostly seen in the market are 3.3 kilowatt and 6.6 kilowatt. It's powered by single-phase power source. For the record, OBC is quite common on passenger car, but not so common for vehicles that's been equipped with a big battery due to limited charging efficiency. Then there's DC-DC. A DC-DC can help converting the high voltage DC from the lithium battery into 12 volt or 24 volt DC, thus charging onboard lead acid battery. The lead acid battery will then be used to power all the other onboard load. In this case, the lead acid battery doesn't need to be replaced or maintained frequently. Okay, compared to DC-DC, I think PDU is more important in power distribution. Relays, fuses, current sensors, or someone might call it shunt, are all integrated in PDU to control and protect the whole circuit. In real practice, functions of PDU has already been integrated into some smaller battery pack. The fact is that OBC, DC-DC, and PDU can all be integrated together, saving space and simplify design. Of course, motor. Most motors in the market right now is either PMSM or permanent magnet, synchronous motor, or induction motor. There's not much to talk about motor because we mainly deal with lithium batteries. However, MCU or motor controlling unit is more important. Besides from controlling the motor, some MCU could help convert the three-phase power from the motor and then send it back to the battery, thus achieving regenerative braking. And the most important component would be VCU or Vehicle Control Unit. It helps coordinate the communication of different components and send instructional signals. VCU is to vehicle what brain is to human being. EVCC, Electric Vehicle Communication Controller. I left EVCC at last because only Chinese-made BMS need an EVCC to convert the signal for charging. Without this, the battery cannot be identified by CCS or Type 1 charging station. Thus, the battery cannot be charged. Okay, and now we're looking at BMS, also known as Battery Management System. BMS is an essential part of any battery pack. The relationship between BMS and battery is the same as that of between VCU and vehicle. For a different project, the software part of BMS will be different, especially the BMS control strategy. And this is a screenshot of the BMS software, which can be used for monitoring, debugging, and testing. With everything above being said, there's one last thing I'd like to brief about battery pack. From cells into smaller modules, modules into battery pack, thermal management, BMS, electrical design, and battery case structure needs to be well considered when making a good quality battery. Okay, and this is pretty much everything for this presentation. It's an overview. We will be focusing on further details in other presentations. Feel free to make contact with my colleague for more information. Everyone here in CTS would be very happy to provide tech support and all the battery related information. Thanks for watching. Have a nice day.